Hey everyone, alongside my good friends and teammate Juba, Jonah and Will, today we're sharing with you a mildly entertaining retelling of our journey through the last 10 weeks. At the beginning of the project, we were given the very daunting project goal of building a boost converter circuit capable of taking a solar panel input and outputting a power across a 50 ohm load resistor. To do so, the team went through a rigorous process of testing through LT-SPICE simulation to determine the best combination of resistors, inductors, and capacitors that yielded the highest efficiency. We'll explore this in more detail later on. Our first attempt at testing, the team faced many issues which essentially invalidated our data. Luckily, we were given the opportunity to have a second go. After fixing these issues, we completed further testing under the lamp in the makerspace and achieved much more promising results. Under testing, we were able to reach a boosted voltage of 6.5 volts and a max power of 630 milliwatts. Mid-range duty cycles, the circuit was even able to reach 85% efficiency. The circuit was integrated with a virtual instrument designed by the team on the program LabVIEW. This VI was able to record and upload data values such as voltages, currents, and panel insulation, and it also incorporated a PID control system that allowed us to modulate either a certain output power at the load resistor or a certain duty cycle for our PWM signal.
Hello, I'm Juba. This part is solar panel fitting and the build the circuit in LT-SPICE. We fit the solar panel first in Excel, and we got the characteristics of the solar panel. Then we pick these characteristics to LT-SPICE, build the solar panel circuits, and then we run this circuit with different temperature. We got the different performance in different temperature. The temperature higher, the performance worse. And then we pick the solar panel to the whole circuit. And the circuit there is oscillator. The circuit there is the boost circuit. So by trying and trying again, we picked optimize the components to build the boost circuit. And when we want to load power out to 0.5 volts, we can get the out power out 0.5 volts there. So next part is build the circuit in real world.
To combat the issue of power loss due to an increase in temperature of our solar panel, our team created a simple cooling system made of an aluminium finned heatsink and a makeshift thermal paste consisting of toothpaste and a bit of Vaseline, while we also created a structural support system to optimize the tilt of the solar panel. Our final test was performed under a lamp, which made any tilt not necessary.
We failed the first test, firstly because we not test the circuit and the software in the outdoor sunshine. We could not get the open circuit voltage and short circuit current of the solar panel. The duty cycle is 0 or 1, which made our battery output, power output, cannot reach our expectations. Outdoor testing made us realize that the sunlight is completely different from lamp in the lab. So we improved the circuit and the software outdoor in sunshine. Secondly, due to the used circuit incorrect, my OP amps and Jonah's were burned and Will's current sense was also broken. We asked the new admins. So in the second test, we succeeded.
In this section, I will be comparing our expected versus actual results from the IV graphs created by our system. As you can see, our predicted IV diagram that was created on LT-SPICE is not very similar to the actual IV diagram we obtained during testing. Despite it following a similar trend to what we wanted, it is not as accurate as we would have expected, which did end up affecting our outputs and making it so our system as a whole did not reach the efficiency we wanted. Although we have not known each other for a long time, our group did a great job in putting together this project. Throughout this process, there were a lot of challenges that came up that we had to tackle as a team. By problem solving and persevering, our team managed to overcome these challenges and work well together for a common goal. I speak for the team when I say that although this project was very difficult, the end product was very satisfying for all of us involved. Thank you so much for watching this documentary. We appreciate your time.